Right, I want to present another further example from the theory of equations, and it runs like this. Show that the square root of 3 minus 1 is a root of the equation ax cubed minus bx plus c is 0, where a, b, and c are all rational numbers, and if and only if a to b to c is in the ratio 1 to 6 to 4. So, we begin by substituting square root of 3 minus 1 for x in the equation, and this is what we get. A square root of 3 minus 1 cubed minus b square root of 3 minus 1 plus c equals 0. That's the obvious way to begin it. And then we expand, and what do we get? A 3 root 3 minus 3 times 3 plus 3 root 3 minus 1 minus b root 3 plus b plus c equals 0. Now, collecting the surd terms, what we get is 6a minus b times the cube root of 3, and the rational terms minus 10a plus b plus c equals 0. Each of these terms must be 0, because the rational part must be 0, and the irrational part must be 0. So we get 6a equal to b equals 6a, and call that equation number 1, and b plus c equals 10a, equation number 2. Substituting in here for b, we get 6a plus c is 10a, which means c is equal to 4a. And so, a to b to c equals a to 6a to 4a, which is 1 to 6 to 4, which is what we were required to prove. So that does things one way, but we've got to prove the converse. So, on the other hand, sorry about the slowness of my writing. Arthritis is my excuse. If a to b to c equals 1 to 6 to 4, then the original equation, then our original equation becomes ax cubed minus 6ax plus 4a is 0. And of course we can wipe the a's out by dividing through, so x cubed minus 6x plus 4 is 0. Now, we can easily show that x minus 2 is a factor. And why? Because if you substitute 2 for x, you get 2 cubed minus 6 times 2 plus 4 is 0. So we can divide the left-hand side by x minus 2, which I shall do down here using synthetic division. That's 1 0, minus 6, and 4. That's your divisor, that's your multiplier. So 1 into 1 goes once, and now we concentrate on the multiplication. 2 times 1 is 2, added to 0 is 2, 2 2s is 4, added to minus 6 is minus 2, minus 2 times minus 2 is minus 4, added to plus 4 is 0. So we indeed get a remainder of 0. So our original equation boils down to x minus 2 into x squared plus 2x minus 2 equals 0. And it's now simply a matter of solving the equation x squared plus 2x minus 2 equals 0, for which we can use the quadratic equation formula, which means that x equals minus 2 plus or minus square root 2 squared minus 4 times 1 times minus 2, all divided by twice the coefficient of x squared, which is 2, and that comes down to minus 2 plus or minus square root of 12 divided by 2, which equals minus 2 plus 2 root 3 over 2, which equals minus 1 plus or minus square root of 3. And so square root of 3 minus 1 is a root of the original equation. And that completes this little exercise. Hope that was nice and clear, and thank you for listening.